Hello all, Javed Basha here. So in this session we are going to discuss about operation research. In this we are going to discuss about linear programming problems. Okay, linear programming. Okay, we know that linear programming is one of the operation research methods techniques we are using to find out the optimum solution for the various business situations or problems we are facing day to day. Okay, here the main objective of this LPP is that maximizing the profit or lowering the cost of production. Okay, here like it is using for the enhancing the productivity. Okay, enhancing the productivity. So we have some definition for LPP like linear programming is a method to achieve the best outcome in a mathematical model whose requirements are represented by linear relationship. Okay, linear programming is a special case of mathematical programming, right? So here linear programming is a special case of mathematical programming in which we are mainly using for the achieving the best outcome. Okay, here best outcome means that we are maximizing the profit and lowering the cost of production. Okay, we are here utilizing this technique for the effective utilization of resources, correct? So in many practical problems in operation research can be expressed as linear programming problems. Certain special cases of linear programming such as network flow problems and multi-commodity flow problems are considered important enough to have generated much research and specialized algorithms for their solution. A number of algorithms for the other type of optimization problems work by solving linear programming and sub-problems. Correct? So, now we understood that what is linear programming. Correct? Linear programming is nothing but it is a mathematical program. We are using it for the achieving the best outcome, or we are using it for the best utilization of optimal utilization of resources. Okay, in this the main focus is should be on the maximizing the profit with the lowest cost of production. So here there are few given problem situations. There are certainly essential conditions that need to be solved by using linear programming, like limited resources. Okay, here we know that factors of production like labors, material, equipment, finance, we know that. Okay, these are limited resources, right? So here limited resources refers to the limited number of labors, limited number of materials, equipments and finance. Okay, objective. Okay, here objective refers to the aim to optimize. Okay, here we know, as we discussed, that here the aim is to be maximizing the profit and minimizing the cost, right? So here objective is always optimizing the things, which means that maximizing the profit and minimizing the cost. Then third important condition is that linearity increasing. Okay, here increase in labor input will have a proportionate in output. Correct. Here if we were going to increase the labor, means that labor input means that will have a proportionate in output. Okay, if you are increasing the 5 number of labors, means that there should be some increase in output. Okay, proportionate output means that what 5 number of labors are working, there should be increasing in the output. So homogeneity. Okay, homogeneity means that the products, workers, efficiency and machines are assumed to be identical. Okay, normally homogeneity refers to the identical things. Okay, identical things. Okay, here identical means what products, workers, efficiency and machines. Okay, here we are assuming these things are to be identical in nature. Okay, the final important condition is that divisibility. Okay, here divisibility is assumed that resources and products can be divided into functions. Okay, it means that we are dividing into the functions or fractions. Fractions. Okay, here so there are few requirements for the linear programming problems, like there must be well defined objective function, right? There should be well defined objective function. There must be a constraint on the amount. There must be alternative course of action. The decision variable should be interrelated and non-negative. The resource must be limited in supply, right? So there must be well-defined objective function. Here objective function is whether it is a minimization or maximization. Okay, the constraint on the amount, what is the amount we are having, and alternative course of action. Okay, if it is not feasible, then what else we are going to do? Okay, then the decision variable should be interrelated and non-negative. This is the very important thing, that there should not be a 0 or less than 0. Okay, the decision variable always greater than 0 and it is positive in nature. Okay, then and the resources must be limited in supply. Correct. So, and there are here we have some assumptions on linear programming or LPP, like proportionality, additivity, continuity, certainty, finite choices. Right? Proportionality means that if we are increasing one unit of input, means that there should be increase in one proportionate output. Right? So additivity means it is always positive, and it should be always continue, and it is certain, and it should have finite choices in nature. Okay, these are the assumptions we are using in LPP model of problems. Okay, it is always proportional. Okay, and additivity, continuity, certainty, finite choices. Right? So these are the important assumptions we are using in the LPP problems. Then there are, what are the applications? Why we are using this special case of mathematical function, or it, as I told that LPP is a special case of mathematical function, right? So LPP has numerous applications in various industries like business, industry, military, economic, marketing, distribution. Okay, these are the few important categories where we are widely using the LPP models. Here, areas of applications of LPP, like in industrial applications, in industry we are normally using for the product mix problems, blending problems, production scheduling problems, assembly line balancing, make or buy problems. Okay, and in management applications we are using in during a media selection problem, portfolio selection problems, profit planning problems, transportation problems, and in miscellaneous applications we are using for diet, agriculture, flight scheduling, and facility location problems. Okay, then here there are few advantages of LPP and there are few limitations of this. Okay, we are discussing one by one. Here, when it comes to advantages, LPP helps in attaining the optimum uses of productive factors. Correct. It is the main objective of this is to be maximizing the output. Okay, with maximizing the output. Okay, effective utilization of available resources. Right. So it helps in attaining the optimum use of productive factors. Okay, here productive factor refers to the labor, machine, materials, right, finance. So these are the some productive factors. Okay, by using this we are attaining the optimum users solutions. Right. So then LPP improves the quality of the decisions. Correct. Here the main motive is always maximizing the profit by lowering the cost. Hence it is helps in the improvising, and it provides the various other options to the management. Okay, which option should be useful or which option should be help to optimize the things. Okay, hence it is always helps in the decision making, right? And it provides better tools for meeting the changing conditions. Exactly, because with the changing condition it is necessary to adapt ourselves, right? So we know that the resources are always limited in nature, so by the help of this LPP we can effectively utilize these available productive factors like labor, machines, materials, and finance. And LPP highlights the bottleneck in the production process. Okay, so these are the few of the advantages of LPP. And apart from this, we have few limitations of LPP. Like for large problems, the computational difficulties are enormous. Okay, and then we have limitations with respect to yield fractional value answers to decision variables. Okay, it may yield fractional value answers to decision variables. Then we have it is applicable to only static situations. Okay, static means constant situation. It is only applicable to only static situations, and linear programs deals with the problems with single objective. Hence, we cannot use for the multiple objective problems. Correct. Hence, these are the few limitations of the linear programming problems or methods what we are using in the operational research as techniques. And here, apart from this, there are few important concepts with respect to linear programming. So we will be discussing in the next session. Thank you, everyone.